Recently, headlines have declared that the James Webb Space Telescope broke the universe. Looking back to the cosmic dawn, the telescope captured images of galaxies that were massive, heavily structured, and remarkably mature. Standard cosmological models predicted small, chaotic clumps of gas and stars, baby galaxies that would take billions of years to slowly assemble into structured spirals. While astronomers were puzzling over these mature early galaxies, a second anomaly turned up much closer to home. Researchers mapping the nearby universe discovered an enormous bubble-like structure of galaxies right in our cosmic backyard, naming it Ho'oleluna. Measuring a staggering 1 billion light-years across, this bubble is significantly larger than expected. Its scale suggests the universe expanded further and faster than theoretical models originally allowed. At every scale, from the expansion of the cosmos to the birth of individual stars, these structures suggest the early universe operated with a speed and intensity we are only beginning to map. To understand how these massive structures formed so quickly, we have to look back to the first 400,000 years after the Big Bang. The universe was a cauldron of hot plasma, where gravity and radiation were locked in a constant physical struggle. This tension generated massive sound waves that rippled outward through the primordial plasma. These are baryon acoustic oscillations. As the universe expanded and cooled, these sound waves froze, leaving three-dimensional density ripples. Over eons, these peaks became gravitational magnets. Galaxies pooled along these boundaries, forming enormous bubbles like Ho'oleluna. The macrostructure of the universe is a direct fossil of those ancient sound waves. They created the high-density nurseries that laid the structural groundwork for galaxy formation. Zooming into one of these high-density primordial pockets, we find that individual galaxy formation bypassed the slow, gentle accumulation of matter. Recent cosmological simulations have revealed a distinct physical mechanism that solves the James Webb observations. It is a process known as wet compaction. Early galaxies were exceptionally rich in cold gas. When they collided with counter-rotating streams, this gas lost its spin and collapsed inward. This extreme shrinkage created immense core pressure, igniting a violent, highly concentrated starburst phase. Astrophysicists refer to these hyperactive, compact galactic cores as blue nuggets. This process forged hyperdense star factories in a violent cosmic sprint, bypassing the slow accumulation of matter predicted by older models. This rapid assembly has a fatal flaw. The blue nugget phase is hyper-efficient at converting gas into stars, making it entirely self-destructive. As the cold gas plummets into the center of the galaxy, it also force-feeds the supermassive black hole lurking at the core. The growing black hole and intense starburst radiation trigger explosive supernova winds. These energetic shockwaves aggressively blast the remaining gas outward, clearing the galaxy's center. This massive feedback loop permanently strips the galaxy of its cold gas, a process astronomers call quenching. All future star formation halts. In the aftermath, the galaxy abruptly transitions from a burning star factory to a dense, compact, and dead stellar bulge known as a red nugget. These dead red nuggets are exactly the mature structures the James Webb Space Telescope spotted in the cosmic dawn. The physical mechanism of compaction and quenching perfectly explains the observational anomaly. Current data suggests our previous models vastly underestimated the brutal efficiency of the early cosmos. The massive, mature galaxies captured in those early images are predictable results of this rapid burst, quench, repeat cycle. Our understanding is evolving across all scales of astronomy, from measuring true cosmic expansion with vast sound wave bubbles to mapping the extreme life cycle of early galaxies. We are discovering an early universe that operated as a highly pressurized rapid forge, hammering out fully formed galactic cores in record time. When a new instrument seems to break our understanding, it is actually succeeding in its mission. It forces us to replace simple theories with the beautifully violent, complex reality of the cosmos.